Getting ready to test the intervals, and so that's what I'm going to do right now. When I'm testing the intervals, I am going to just try numbers in between here, and I'm going to put them into the first derivative because I'm curious what's going on with the first derivative. Is it positive or negative? So I don't actually have to come up with the exact value. I just need to know if it's positive or negative. So if I test 3, that would be something greater than 2. So if I put 3 in here, I notice I get negative 4/9. So at 3, it would be 1 plus negative 4/9. That would be a positive value. So I'm going to put a plus sign above here, meaning the slopes of the tangent lines at the curve are all positive in this interval. If I try 1, put 1 in here, I get 1 plus negative 4 over 1. That would be a negative number. So the numbers between 0 and 2 are negative. All the slopes of the tangent lines are negative, meaning it would be decreasing. If I try negative 1, I have 1 plus negative 4 over negative 1 squared is 1. So I still have a negative value here. And then if I try negative 3, I have 1 plus 4 over negative 9, which would be another positive value. So that means the slope of the tangent lines are all increasing here. So what I'm able to do is identify those open intervals on which it's increasing. It's increasing from negative infinity to negative 2. Okay, because negative infinity is over here, up to negative 2. And it's also increasing from 2 to infinity. So those are my increasing intervals. It's decreasing from negative 2 to 0 and from 0 to 2. Let's try another one. On this one, I think it's much easier. We're going to find the critical numbers, and then we're going to find whether the function is increasing or decreasing. And on top of that, we're going to locate whether we have relative maxes or mins. What I was getting ready to say is I think it's easier in this one to actually not use product rule and actually just go ahead and multiply what is x plus 2 times x plus 2. Multiply this out. So I'm going to go ahead and do that. I get x squared plus 4x plus 4, and then I have x minus 1. When I multiply these together, I end up getting x cubed plus 3x squared minus 4. Now you may need to multiply those all out and to come up with this value, but to save a little time, I'm going to go ahead and just tell you what that equals. F prime of x then ends up being 3x squared plus 6x. Now we're looking for those critical numbers, so we're going to set this equal to 0. There are no values we need to test where the derivative does not exist because there's no fraction. We can factor out of 3x, and we're left with x plus 2. So that means there's two values I need to try right now, when x is 0 and when x is negative 2. So what I'm going to do is I'm going to create that number line that I did in the last problem. I'm going to label it this time f prime. I'm testing f prime. So I'm going to go back here and I'm going to circle that. I want to test the intervals. Here's 0, here's negative 2. We know that the slopes of the tangent lines are 0 at those. What's going on before it hits negative 2? Is it positive or is it negative? So if I try negative 3, and I put negative 3 in for there, I'll have 3 times negative 3 squared plus 6 times negative 3. Well, that is 27 plus negative 18. That's a positive value, so I know that all the slopes of the tangent line of the curve are positive here. Then if I try negative 1, I'd have 3 times negative 1 squared plus 6 times negative 1. Well, that would give me 3 plus negative 6. This is a negative value, so all the values are decreasing. All slopes of the tangent lines are negative. And then the last one, if I put 1 in there, I'm going to get positive, so I know it's increasing there. So I'll go ahead and first just write down that my intervals of increase are from negative infinity to negative 2 and from 0 to infinity, so those are increasing. And then my interval of decrease is negative 2 to 0. Now I'm also supposed to find those relative max or mins. What I like to do is I like to just go ahead and pretend that this is partially a function here, and I like to draw in, okay, well, it's increasing, then it's decreasing, then it's increasing. So I know here's max and here's a min. So I'll go ahead and write that in here, that negative 2 comma something is a max, and 0 comma something else is a minimum. We go back to find our y values from the original. This means y. I'll just go ahead and tell you what you get when you plug those in. You get 0 and you get negative 4.